now and do it now. If you're not already, then like I said, you're wrong for that. But look at the do now. You're doing now. Should have already rolled out to you a little bit ago. And work on that. Hopefully I'll get it. We'll get moving sooner this class period. And go dogs.
Mr. Ryan, are we turning these in?
I'm gonna check. Hey, so what do you know? What?
Oh yeah.
Also do now.
I can. We're going for yeah, that was what I watched off.
But sit on that boy, you're just lost.
I like the handle.
Thank you.
I heard grandma.
I was supposed to be a cowboy.
Alright, I say this advisedly, but no one is allowed to go quarantine the rest of the time, okay?
Cool.
At least through the end of next week, because we're doing the flame test lab next week. We'll have only 3 absences right now, and that's great. It means 30 of you are here out of 33, so the flame test lab will not be missed by many. But I want you back too, you 3. So hopefully you're watching this.
They can't quarantine me for next weekend.
They still can.
Jake, if I've learned anything, they can do whatever they want. And I have no freedom to do whatever I want. If what they want is different than that.
I think the basket.
Stand up to it.
Man.
Yeah, what do you think about
Turn the
that?
light off and tell us your teacher.
Like, it's not even going to help anything. You're still going to get quarantined.
Like, are you though? I thought if you're wearing your mask and you're 3 feet, you're quarantined.
They still do.
I thought
That's
they
how it
weren't.
was last year.
That's how it was last year. This year they looked at the and you weren't here for the announcement. And they announced literally that if you're within the 3 feet number and you wore a mask and they can be verified, then you won't quarantine.
Where are they getting these numbers from?
Which numbers?
The 3 feet.
Because last year it was 6 feet.
They
This year it's 3
it was
feet.
there's some
You're the end of last
they
year.
basically they went over here and they went like this and they went real deep and then they went and said, here. There was one of the they that went was real deep. Like they had a doctor with a gloved finger and just very much. But you know what? The good news is they didn't have any polyps and they didn't have colon cancer. So winner, you know. But what they pulled out was the 3 feet and the 6 feet number.
Okay.
That is so stupid.
Thanks for that.
Good on.
I hate wearing a mask.
Amen.
You ready for the game?
You know, some other cool things. Yeah. This thing also, just straight out. Voila. Because,
Even though it's been proven not to. Yeah.
And it went 2 masks and it was like,
anyway, I'm trying to take the same tack I take about, you guys getting your work done and having issues and live stream, stuff like that. I'm trying to take the same tack with some of that stuff. So, I just would love someone to answer my questions. I just would love it. My favorite answer is, well, I'm a doctor, so you should do it because I said so. Right, okay. But we're rational human beings. We don't live in that kind of society. We're rational human beings to the extent that as much as I'm willing to listen and try to reason through it, please provide me a reasoned argument as to why I should do anything. Like fill in the blank. Just tell me why, and then let me think of a rebuttal, and then get back to you. And if you can defeat it, you have a defeater, I will submit to that notion because you have a defeater to it, and I'll just respond to the logic with logic. But if you don't have a defeater, you just have a feeling like, well, people are dying, so you got to be afraid of it. You got to be afeared, because I said so. As true and real as it is killing people, and it is very scary. That can't be the crux of a decision. Like, the fear factor. Statistically, what's it doing statistically? Because like, what are my odds? And then I want to know, what are my odds to the things that I used to risk all the time without thinking about, like driving on the road to get here. Statistically speaking, you guys, your age group, you know what? You survived the car trip here. The odds were better that you wouldn't, than also have a severe reaction. Forget about death. A severe reaction to the C word. You know what I'm talking about?
Crash.
Yeah, you're right there.
But anyway, but that's just numbers. Like, what do they even mean other than like what you used to do on a daily basis prior to 2019? You didn't assess risk intrinsically or extrinsically. You just like, I'm gonna get behind the car. I know I need to drive a certain way, and if I drive off the road and jerk back on the road, I could hydroplane, I could flip, things can mess up. Like, I should just be careful. Like, that's just like a thing. Like, I should do. Like, I don't want to bring harm to myself. But anyway, keep going. About light. Your thoughts. So your answer to be right. The only wrong answer to this is a non-answer. You have no?
I just like it. Timing all the way out.
Change the wiki to the other place. Whoever just change it to a different one, sometimes we work, sometimes we don't, sometimes we don't.
Thank you, Kevin.
So this is on your back. Yeah, this one's fine. So that's not gonna be all right. So it may be, you just grab units, and then this one you just really, here's the big bulk. That's probably and then you get that not aligned with what you would expect.
What is light?
Every day, somebody's responsible. Only yourself.
Does that make
Thought you had your bag way? So, I can tell you just the majority of this one, you got 5 points out. You can set up your own come through. Also, the majority of the time, are you on the oh no, you on your work. You didn't show your work.
I put all my sources here because it's hard not to say just because of how you get rough settings. Oh my god, I was like, I'm taking this and I'm going to go plagiarism check over to make sure I had everything. And it's not, and for like a website that turned in, it said my name was plagiarized because on another essay that I used, I had to have my name. It was like, I like looked at it, and I was like, oh, it's on my name.
Wait, numbers were like after like just
Do you see what's your favorite? It's pretty
Look, guys, that's the large company.
You would. What, is it 1 cent for each question or 1 cent for each classmate?
I'm aiming for everybody.
It said 1 cent each is a good target. Is that because of classmate or picture?
I didn't ask for
where do I find it? I didn't.
for each question, per classmate, so a total of 6. Each classmate has 3 answers, so when it's for each classmate has to do it. Here's what I light is made by electrons, so without electrons, it gets transferred.
You hear me?
I don't know.
Good, I like that.
I just X'd out of the back.
Mr. Knight. Jake, I see responding to your comment, dude.
How do you reply to these? Are you just like, yeah, that's right?
Wait, what do you come from?
Like, it says how it works. You answer the question and respond to your classmates' comments. And you say, like, yes, that's right, no, that's wrong, or
What do you mean?
like, when you turn in.
Do we only like do one of them? Select one of them?
Well, I'm thinking that
I was getting a number on it.
But there's nothing to say here. What did you respond to my thing? That's what you put? Either.
Should feel.
Okay, I'm gonna get these.
That's crazy.
By the way, this is college style question type stuff where you have like
So
a
did you only put
prompt,
one
you go and
answer?
answer it online, like a online college class. You go answer it online and then you respond to your classmates. This would be like you give like a short appraisal of someone else's comment. Like you go in there and be like, I like how you said, how you described what you thought about light. Or
Okay,
when you mentioned this, that was a good analogy. You know, that's just
Your
like you
answer.
just comment on something specific. Huh?
My replies might have been a little less.
Yeah, like good work, nice job, like you rock. Those are all nice things to say, but also wrong for those problems.
Mr. Noise, good work. So, can we answer all of these on here?
Everyone got it.
Anybody else?
Wes.
Oh, yes.
Just you.
I need to call on
Now, I think
Friday.
that is below what I expected. But
It doesn't make everyone not have.
so I think when you get a chance to look at that, I think you'll come to see what occurs and how
I'm gonna put a link to a video that has Muhammad portion of Allah. You know those scammers that are on YouTube? And like they'll just like they're getting to an argument in the comments. They'll just like send a link to you. It's like
Wow.
wow.
Do you have to?
That wasn't very positive. Positivity. Am I right, Mr. Knight?
you were right.
Alright.
I can say I'm screwed.
Where was that good one? Yeah, Jesus, I noticed that too.
What? From magnets?
Keep moving, you magnet.
Is that any dishes? Oh, okay. I'm not even gonna bother today. I'm not gonna yell at you today, that's my goal. Okay. Breathe in.
I will show you pain.
Jake, I replied to yours and I said David.
Fixed. Set and stuff. So
Technically, it's
don't freak out yet. And it might get typed in that way because I was in a state.
Can you unmute my comments?
oh, absolutely.
I mean, that is a
I found out there's 4 people that are gonna message me about your around 25.
Hopefully that one log that posts everything on Facebook.
Can you unmute me?
That's not the same deadlines that we've had before, but what do you have? Alright, so, never mind, we'll save the rant. You can, look, I'm gonna pause this for a second if you're online.
Oh my gosh.
All I'm trying to say, you know, but we don't have to be mean. Like, I got some, we can share some ice cream at a block party. You're going to sit in my yard and tell me things.
Go look at Jake's
See, I'm not
answer.
mad at people who are mean. I'm mad at people who are unreasonable. Why don't you just be moderate for a second? Just one of them. One of the seconds. Oh, I mean,
It wasn't the principal that decided it. They said they're taking all exceptions, all suggestions except going virtual. So we're not going, no matter how bad it is, because they don't care. Garnto doesn't care. Garnto, you can have a flood outside your house and be like, get yourself a boat and be here by 8 a.m. No, it's.
no, there are more options than that. It's not just boats. You can build a bridge and get over it.
That's true. I feel like a row would be slightly quicker than a bridge.
But you better make
Or
it
you
here
can
at
get
8
a long,
a.m.
like firm pole and just jam it into the ground and jump on it.
Oh, Lord.
Yeah, pole vault. That's what the word is.
I feel like that's going to end in a lot of concussions, though.
These are we're opening all kinds of cans of worms here. So
I mean, as long as
Right
you make
there.
it to school before 8
Building a
a.m.
whole bridge
building a whole bridge.
for that one day.
I'll go. All right. So far, this my plan for today has been far exceeded my expectations in the worst way, in a bad way. Me, I've done this. This is me. So should be not just points for you per se, but points against me. Like I should be losing points. Nevertheless, me saying that right now is also doing detriment to what I had planned. Anyway, so the nature of lights and what we're going to talk some more about that. We're going to answer those questions. We're going to close the gaps on some of those a little bit. So you can finish whatever thought you're on, whatever. Close your lid. You can be done with that once you've answered. If you're still finishing, you can do it. You're foldable. Let me just go ahead and check it right now. It's 5 minutes now, 5 minutes later, so I'll just check it now. Get my grade book. Grade book out. Get my grade book out. Come on now.
They're pretty much.
That is so pretty. Did you get the fishing picture notes?
Yes.
You did?
I think. Hold up.
Hold up. Yeah, I didn't feel about I don't know if we're supposed to.
Different, get out.
Find it, Ethan. I'm gonna cry now.
That's how my dad left.
My dad left and then moved and then he was like living all the time.
My dad left.
How random is this?
Haley and who else?
We're gonna find my fish infusion.
Look at how pretty mine is, y'all. It's like vibing right now.
It's like totally rad.
Yeah, you see,
How'd you do? Did you get race history?
she didn't have to give did that stand out to get papers and stuff, so maybe your notes are either this.
I did that.
I wanted to keep it.
So it turns out I gave it to my mom last Friday. I had time to Dexter with this. And I was like, hey mom, I need to try the outside stuff on weekends. It's a teaching stuff anyway. Yeah, so she put it back in my room after I was out.
Hold on, I'm trying to find mine.
I'm a paper.
Are those like handwritten notes or?
Yeah, those were the handwritten.
I gotta find mine.
There were like some slides after this.
I know what you're talking about.
Yes. Did you do your Fusion Fusion notes?
I know I did my notes, but I gotta find mine.
I know this the app's not.
Can you give us a second copy?
Not right like that.
I know I did it now.
I journey. I can't drive.
Yeah, I mean, it's really bad. She already has I don't feel bad. Because I was like, I'm trying to wait for him to do
I know.
All right.
So on light and nature of electrons. Hey. Yeah. Flip it over. Okay. So what about your fission fusion notes? I'll say again.
I did do it. Mr. Knight almost called the game today.
For days.
Good.
For days.
Good. So there were 14 total slides to look at and pull notes from. If you just did the foldable, that's 9. There were 5 others. No. Show me again. Where is it? Can't see it. Yeah, I got it. Okay, so it's actually less relevant today because we have not gotten to fission fusion in any class today, so it's fine. Sort of fine. It's also not fine because you need to get them. Like you still need to get them. You still need to get them. Especially you need to get them because there will be use of them in preparing for the exam, as will be made evident. But also, you need to prepare with the information that I'm assigning. You know what I mean?
Yes.
Like if I assign it, it's definitely that important. Okay. As a reference material. But anyway, hi, yesterday we talked about electrons and their just weirdo wackiness.
They are. And maybe improved it.
It is so weird how they act. They're just always weird. And they're mysterious and unpredictable. The bottom line is that their unpredictability ends up lending themselves to, for us, our understanding of tracking the path, the movements of an electron, is sort of difficult, but what we can understand is that they have a range of possibilities. And those possibilities are bound, right? Think about the electron going through the double slit. The electron can't decide to go, it can either go through one slit, the other slit, no slit, both slits, or bounce off in various different ways, but it can't head towards the double slit and become a banana. It's not going to head towards the double slit and then explode on the whole double slit experiment. Are you with me right now? Like there's a range of possibilities. Are you there? What this tells us is that the electron will follow a path that fits in a shape, a predictable shape. So it's anywhere along that shape is its path in 3D around the nucleus. Hello?
Yes.
Are you there with me right now?
Yes.
So all that really means translates in the chemistry realm. In a profound way, all of the double slit experiment and the implications of not knowing of an electron behaving one way when you're paying attention and behaving another way when you only observe the results is that your act of measuring inserted yourself into the frame of reference there. You willingly chose to insert yourself into the discovery, into the situation the electron was living in. And by doing that and measuring, the electron consequentially only behaved in one of its possible ways. Are you there with me right now? So your action had a consequence that was fixed, though one of several possibilities. Hello? Which this just means your decisions matter. This means you have autonomy to make decisions. You don't get to decide the consequence, but the consequence will fall in a realm of possibilities. Hello? This is pretty good. It means your decisions matter. It means you have personal responsibility. I mean, this is like proving a sort of anti-Marxist nonsense that's spouted by New York City morons sometimes. More on that later. That's what I meant. More on that later. Anyway, in other news, I just got so off track. That took me off the rails this time. Oh, but what this does is it begs the question, okay, if electrons can behave in such a way that breaks our understanding of time, space, matter, and physical realm, we are bound to it. Electrons are bound to it. When we measure an electron's path and what it does, the electron's bound to time, space, matter, and physical quantities. Are you there? So if it can behave outside of that, from what does it derive the ability? From what does it derive this superpositioned notion of all of its possibilities? Where it's got to be able to derive it because it breaks the rules. Where does it derive its rule-breaking behavior? Hello? And that really, honestly, it begs the question. There must be some entity outside of time, space, matter, and the physical universe that can infuse the rule breaking. Hello? And by rule, I'm not talking about like laws and rules. I'm talking about like time, space, matter. Like an apple, you throw an apple up and it just stops in midair. Like that'd be physical laws, rule breaking. Are you with me? So that has to be derived from somewhere, which begs the question: from where does it come? If it comes from anywhere, it must come from an entity that must exist outside of the time, space, matter, physical law continuum. What?
Yeah.
That would be a three-letter word you've heard before. Sure. That would be speaking of something that's synonymous with helium. Anyway, which this actually brought some scientists to their physical, personal knees. They just like couldn't deal with the fact that the double slit experiment might mean that there's a God because they were atheists, and made them realize, wait a minute, I choose no God because I don't want there to be a God, and that just bothered them so much that they took their life. Unfortunately, there's some scientists who did that, and I was like, what? It's crazy. These scientists, there's a scientist who literally the results of this thing, in his mind, so profoundly evidenced an existence of God, and he didn't want to believe it because he thought, I'm going to have to be subject to that God, or my life actually, there is a right or wrong that I might have to be subject to, and I don't want to be subject to anything but my own hedonism. And so he was like, well, I don't want, so he ended it. Which was really sad. I just feel like a couple hours of conversation at the Starbucks over Frappuccino, chocolate chip. We'd be like, we'd clear some things up, you know what I mean?
Yeah.
So it's really sad, but also, how profound. Wow.
Yes.
Anyway, so before we move on, I want to show you something about double slits and such. Double slits are just called diffraction gratings, is more or less how it works. here's a set of diffraction gratings. There's a single slit, a wider single slit, a slightly wider single slit, a close together double slit, a slightly wider double slit, and then a wider even still double slit. And I'm going to shine this laser through the slit so you can see how waves behave in a pretty cool way. This is kind of cool. Just it's not really that cool per se, like in and of itself, but relative to having never seen it, it's kind of cool. So you have to bear with me as I try this. Right, laser. Hello. Mm-hmm. Get it pointing right there. Laser.
Wow.
Whoa.
Wow.
Wow. Whoa.
Yeah,
Jesus.
Okay, and then here's through that's one single slit. This is a single slit, slightly larger. All right, then here's a single slit, slightly larger still. Ow, my eyes. All right, and then here's through two slits.
Wow.
Here's through another two slits that are slightly further open.
Amazing.
No.
What do you think?
These are wave crests passing through the double slit and interfering with each other, spreading out, interfering with one another, and then where they constructively interfere, you get the dots, and where they destructively interfere, you get the spaces. And here's through double slits right there, further still. Sorry, y'all. Look at that.
Wow.
Here's some other diffraction gratings that are variable.
Oh, wow.
Oh.
Here's some other diffraction grating that's a plus sign.
What?
Ooh.
Here's another diffraction grating that's like this, whatever it is. Here's another diffraction grating.
No.
That's
Wow.
even cooler. Wow.
Cool. So it spreads out, interferes, that's where you get the dots from. So pretty neat, though, right?
Pretty neat.
You've never seen diffraction setup before. Okay, so electrons, right? They're weird. They behave. They exist in space around the nucleus, but not necessarily in a circle, not in a sphere. Some do, but not all of them. Most don't encircle the nucleus in sphere. But they do orbit the nucleus in some shape, though not circular, still around. So they're like orbits, but they're not really orbits. They're like orbits. Are you there? So we had to come up with a word that's like that, orbital. Everyone say orbital?
Orbital.
So we'll talk more about those orbitals. We kind of already mentioned when we talked about the SPDF situation. Those are the four shape categories of orbitals. Four kinds of orbitals. Hello? Cool. All right. So how do electrons have to deal with light? What do electrons have to do with light?
Like, you know how light exists in like electromagnetic spectrum. Electrons like in the electromagnetic spectrum, if I'm understanding it right, or existing in that plane, helping light, like in wavelength. I don't know. It's like I know it's there. It's just like it's coming back.
They're related.
They're related.
And the electro prefixes have something to do with that, maybe? Okay. They are related, certainly. What else? Does anybody have any other conjecture? I'll read about them later, so it's fine. But, so get this, electrons, they exist in their orbitals, yes?
Yes.
And Bohr has identified that in their orbital situation, arrangement, they possess a certain amount of energy because they're moving. And they have to stay moving to stay at that orbit, or else they'll crash down, or if they move too fast, they'll spiral off. Okay? But in their they have a certain amount of energy as they move in their orbitals. And remember on the periodic table, the way we labeled periods tell you number of energy levels used. This is because electrons may start or exist at one energy level, but can jump to higher energy levels because they're available. Hydrogen, for example, uses only the first energy level with only one electron roommate in it. Are you there? That electron, though, can jump to other energy levels, but in order for it to, at its current energy level, move to a higher energy level, like literally level of energy, it must receive what? Energy.
Wow.
So when an atom receives an energy, it actually, the electrons are what receive it. Almost shielding the nucleus from receiving it because it would lead to too much instability. The electron receives the energy, or its electrons. Those electrons, if they receive enough energy, they'll move up to a higher energy level and stay in what's called an excited state. It's energy received, it's kind of excited. It's temporary though, because eventually they'll fall back down because the excited state's not stable. You're familiar with this. If you've ever had Mountain Dew before, or anything with lots of caffeine or high sugar, or if you've ever taken care of your siblings or young children who have had those things. Yeah? What happens to them?
You're really excited.
They get real, they go crazy, they're excited, they bounce off the walls,
And then it has like
hyper,
Yes.
but you can always count on
You're going down.
they're crashing later. Now they're gonna crash. I wish they all crashed sleepily. Doesn't always work out that way. Sometimes they crash fussy or mad, cry baby, like they just cry, like, come on, can't you just go to sleep instead of just crash out tired. Don't crash out like, oh my goodness, hold me. Oh, goodness gracious. Hold yourself. No, just kidding. I'm not so hard. Electrons behave similarly. They receive energy, they crash out. The only difference is that electrons must gain an exact amount of energy, or they go to occupied energy level corresponding to an exact amount of energy. Are you there? So let's just say if energy level 1, N equals 1, their symbol represents energy level, means N. I'm actually in this same class today. We're going to tell you something else that N can equal, but that's totally unrelated. An electron at energy level 1 can receive, has 100 units of energy. We're just going to say units here. Can receive 99 units of energy and move up to 290 or 199. But it's not enough to reach the second energy level, so basically nothing really happens. The electron gets energy and it falls right back down instantly. Okay? But if it receives exactly 100 or over 100, just slightly above or above, it will be excited as it's like roaming through the halls of energy level 2. Think of it like an elevator. If you go up to higher levels of floors and you think you're like not supposed to be there, like personnel, authorized personnel only type of thing, like you're really antsy about it, as you go higher up, you're like, oh my goodness, I'm getting higher. I might get caught up here in the penthouse suite or something. You know what I mean? Can you just imagine it? Okay? It's a strange analogy. But if you went up, as you get further up, you're getting a little bit more like, there's more expensive luxury things up there that I might break, you know? Like you're just going up the elevator. You can't stop between floors. If the elevator stops between floors, you're not getting out. You know what I mean? You have to wait till you get to an entire floor. So if the elevator only had enough juice to make it halfway, you don't get to go to the higher floors. Hello? It needs all the juice to get you further, and it only stops at the floors. This is how electrons will go. In fact, if an elevator goes halfway between two floors, it'll settle back down at the next stop. Are you there? These are how electrons behave. If it receives 100 units of energy, it'll stay excited at the second energy level. If it receives 150, it'll rest back down temporarily at the second energy level. If it receives 250, it's going to the third energy level. If it receives 249, it's just below. It'll stop and rest at the second energy level. Do what?
What if it got any more than that, where it just jumped to an extra energy level beyond that?
If it got just more, it'll settle at the third energy level.
Like a significant, like crossing the next threshold, like is there another threshold beyond 3?
It can go up to 4, 5, 6, and so on. Yeah. But bottom line is that it can move up an energy level. That's called a transition. Everyone say transition? But that's temporary because it's excited and unstable, so it'll crash back down. When it crashes back down, it now has less energy than it did for that temporary state. Has energy, gains some, falls back down, meaning it lost it. Where did the energy go? Light. The light is released from the electron. The electron receives energy gets excited temporarily, crashes down, on its fall, releases light. Now imagine that process occurring for multiple electrons. Some's going from level 1 to 2, or level 1 to 3, or level 1 to 4, or from level 2 to 3 and 2 to 4, or from level 3 to 4 and 3 to 5, and so on. Multiple electrons on one atom, and then trillions of atoms with all of their electrons happening simultaneously, and not exactly simultaneously, just some offset by a little bit of time, and then they're overlapping because they're not like waiting on each other to take turns. They're all just going as they have energy received. Rising and falling constantly all over the place on trillions of electrons, trillions of atoms. Are you there? That's what's coming out of these bulbs. So that's how light is coming out of these bulbs. That's what's happening right there. Filament in the light bulb, same thing, it's just made of metal. Gas in this tube is just gas atoms in this tube. That's a legit one, that's not sarcasm, that's like...
Wow.
Oh, y'all knew that already? So we'll just keep going then, y'all don't need any more information on it. And, oh wait, hold on, William, do you still have your question?
Yeah, so I was gonna ask if this car's at a certain level, after it increases, can it go back to a level, I guess you'd say like, lower than the first, like it starts at?
No, it will always go home. If it jumps from 1 to 3, temporary, it'll fall straight back to 1. It won't even slow down at 2. So that's where it differs from my elevator analogy. But good question. Okay, great.
So whenever a light, you could say like if you blow on a bulb, what happens like in that? Does it just like go down too much and then they're all down, or
So-
like, is it just on too high?
So I'm gonna have to speculate on these, but like a filament, for example, that metal, the metal that makes up the filament just gets worn out. It's just like overused. It's tending towards chaos, and in its chaos, it comes detached from the circuit, so it's not receiving a complete circuit of electron flow anymore. So the bulb doesn't function. In terms of gases or light-emitting diodes like LEDs, LED lights, are just tiny little, basically electrical charged plates. And I don't know what's in between, but I assume a tiny piece of metal, and they all together are individually receiving power, and the electrons in that small space, whatever it's filling it, is excited and releasing light. LEDs last a long time though, because I guess the materials just have a lot of life in them. Like they just have a lot of durability. So in something like this, my best presumption speculation is that the components that transmit the energy to the tube, those start to break down or corrode. The environment just kind of wears away at it. And so it's not getting electricity efficiently to the gas. So there's only enough energy for the gas to power some electron transitions. And so not 100% of electron transitions are taking place. Like this tube right here appears pink. That's because not enough electron transitions are taking place. So much so that you can actually see, it looks like there's a wave of flow of like a dark band that passes through. The overlapping is not covering up the transition fall period. You're actually catching up some rhythm to the transition fall. You're actually catching up while transitioning it appears darker. While it's falling, it appears lighter. Also, lower energy amount produced would correspond to a red color. So there's less power getting to the gas, therefore fewer electrons are transitioning and with less energy, so it's producing red light. Alyssa, you had a question next? No.
I was pointing to that one.
Yeah, that one. Yeah, that too. Michelle.
So is the reason that some of the other bulbs don't flicker because they have some energy passing through, they overlap and it's continuous?
Yep. So you're never really catching anything. Every bit of light you see is constantly produced by the crash.
So there's no manufacturing synchronization, it's just fast.
Yep.
Okay.
They're just overlapping. It's like, that'd be like if we're saying, some people will sing row, row, row your boat.
Okay.
And like when I say the second row, Ethan will start. When he says his second row, Wes will start. And so you got like these overlaid tracks of row, row, row your boat going on. They're singing row, row, row your boat, except the tune is in the form of a light wave and not a sound wave. But they're singing row, row, row your boat, but they're like, to a nanosecond, they're syncing up. Like one starts its crash, while the other one is 1 nanosecond later starting its crash. Next nanosecond later starting its crash. Next nanosecond later starting its crash. Have you ever seen how LEDs, when you flick a switch, they don't immediately come on? Or whenever you turn them off, they kind of slowly fade? Same thing's going on here, as the energy is dissipating through a series of capacitors, actually, that are storing energy for a moment, and they pass through the LEDs. They take time to get through all of them, and then they take time to dissipate from all of them.
Wow.
But all the components that make it last longer, gives it more durability. There's easier components to last longer, even though there's more components to it. So, what else you got?
Wow. Yes. Come on.
Wow. Yes. Okay. Cool. That's the verbose version of it. We're going to watch it up here too for you visual learners. So light, first of all, frequencies of light can fall that we can see. Frequencies of light that we can see fall on the color spectrum, visible light, which is actually the tiniest sliver of measurable part on the electromagnetic spectrum. The rest of the electromagnetic spectrum, do you know it? Radio waves, microwaves, infrared, radiation, visible light, ultraviolet, X-rays, gamma rays. Yeah, there's a real song. That's about the tone too. Like I'm pretty, as bad as my voice may be, that still is the tone of the song. That's how the guy who made it. Oh, we gonna listen to it. We gonna listen to it. Huh? Not my voice. We're gonna watch it. Why not my voice? Because I didn't make the video. Bottom line, there's also the visible light spectrum follows Roy G. Biv, who's a colorful man who proudly stands at the rainbow's end. So, you ever heard that one? That's another one. Roy G. Biv is a colorful man who proudly stands at the rainbow's end. Hello? He carries the light of the whole color spectrum. There's a harmony to it. You'll catch on. Anyway, interesting about red is it's on the side of the electromagnetic spectrum. You remember what the step in the electromagnetic spectrum that comes just before red? Infrared. You know what infra means? Below. Can you believe that the electromagnetic wave that's below red is called below red?
Wow. Yes.
Ultraviolet also means above violet.
Who would figure,
I mean, it's crazy. It actually doesn't. They should have used supra. They should have called it supraviolet if they want to be consistent. Infra and supra, those are the opposites. But instead, they were like, no, this is like not just violet, it's ultraviolet, like power thirst, So just really going all out on the naming. Anyway, big things to take away as far as energy and what you need to pull from this slide is that higher energy is associated with the violet end, and then you could go from there. Ultraviolet, X-ray, gamma rays, those are the highest and increasing energy section of it. Associated with high energy is high frequency. And associated with high frequency, as you can tell too, the wave crests come more frequently. That means wave crests are closer together. So they have, here we go, this is going to learn you something right now. They have short wavelengths. Hold on, you're not catching what that is. Short wavelengths. That is, it looks like a Y that's upside down and then mirror imaged. It's the Greek letter lambda, and it means wavelength. Yeah, you're learning that right now. That's learn information, because who knew that? Yeah, you liars. Okay. Low energy corresponds with the red end, and infrared and lower gets lower energy. And they have long wavelengths, and low frequency. So a mnemonic to help remember this actually just corresponds with the low, long, low, 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 long, low, 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 long, low, 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 long. You just have to remember that it's associated with the R part of the spectrum. Electromagnetic spectrum, this lower energy, longer wavelengths, low frequency is on the R side. Radio waves, microwaves, infrared, and then red. Hello? So if you can correspond the r is with the low, long, low, then the opposite would be true for the violet side. Hello? So just like if you're trying to memorize stuff, the cool tip for memorizing stuff is you memorize stuff where if I just memorize this minimal amount of stuff, I can automatically, just by being a nose breather primarily, remember the other stuff too. You know what I mean?
Yes, sir.
Okay? So that way I'm not memorizing violet is associated with high energy, high frequency, short wavelength, while radio waves, and red is low, long, low. You just memorize one of those, and then the opposite would be the opposite.
Wow.
Just a study tip, free of charge. Yeah, mouth breathing though is associated, has been associated with ADHD, just for the record. Some preliminary studies suggest that mouth breathing at night while you sleep may lead to an oxygen load on the prefrontal cortex, and it's an overload on the prefrontal cortex. So it like causes your ability to stay focused and judge and appraise situations moment by moment to be over and hyperactive, which may be tied to your ADHD symptoms.
Wow.
And literally they recommend, from the same study, they recommend breathing exercises where you just focus on not breathing through your mouth. And there you go. You can like just take the next 7 breaths through your nose, and wow, you can start to focus better.
Wow.
Theoretically. Also, if you put crystals in your pocket of various kinds, you'll feel better and healthy and stuff. Anyway, let's keep on going. So check this out. Slits, electrons are the reasons for the light produced. Hello?
Oh.
And each element has a different variety amount of electrons. Yes?
Yes, yes.
Their electron behavior when energized is characteristic of the element. Meaning, hydrogen has 1 electron that can undergo 6 transitions. 1 to 2, 1 to 3, 1 to 4, 1 to 5, 1 to 6, 1 to 7. 5 of those 6 transitions, when they crash, the electrons will produce a light that emits and our eyes can detect as a certain color in the visible light spectrum. The 6th one, the 6th electromagnetic wave that comes out is either infrared or ultraviolet.
Wow.
Isn't that neat? Every other element afterward has those electrons and others that can synchronize, resonate, and create rhythmic sets where further out electrons behave first. And so each element has its own pattern of electromagnetic light produced. Hello? This is called emission spectrum, atomic emission spectrum. Each atom produces its own atomic emission. Each atom, each element can produce a spectrum band of colors, some visible, some not, that's unique to it. So much so that if we took samples that I had, say sitting for over a year, and they've crystallized and a lot of the water was evaporated out, and they're on wooden splints, and then you took a Bunsen burner, heated up a flame, and then put it over that flame, if it burned up the crystal off, the flame would change colors according to whatever you burned. Different chemicals, different elements, when burned, produce different color flames because their electrons are behaving differently.
Wow. Wow.
Like what we're going to be doing in a lab next week.
Cool.
Flame test lab.
Yeah.
It would have been today, but there were just too many people absent for the whole quarantine deal. So we're just going to postpone it next week until we get more folks here. Hello?
Hello.
Isn't that amazing? We're gonna start a fire in here on purpose.
Yeah, you're supposed to do.
Actually, we're gonna start like 8 fires.
That happens all the time at home.
Hopefully 8. Whoa. Like you work for a fire department? You're practicing? Oh no. All right. So the understanding that electrons do these transitions and produce a light emission spectrum, and each electron is kind of behaving separately, and each atom, because of its electron constituents, produces different colors of light. This is what led to the understanding that they must exist on energy levels to behave and make these transitions. Like, this seems like a pretty big leap, but somehow they've been able to coordinate this over the course of years to say electrons exist on energy levels. So here's another just little quick refresher on what happens with electrons. I verbalized it, we talked about it, watch this visually. Everyone say ground state.
Ground state.
Electrons energy level they begin at is called ground state. Say high electron. Everyone say ground state electron. There's energy. That's a ball of energy called a photon. What's up, photon? Energy absorbed. Transition. Excited electron. At the new excited state. Oh, nice. Come on, dude. No, we're just gonna go. Let's see it. Excited state. It's not stable though, so it crashes and releases a color of light that corresponds to the energy it received and fell with. The energy is on the red side. That's a high or low? Low energy. Sort of like some of y'all, the way y'all look right now. What if an electron receives more energy though?
It gets excited.
Super excited. Not just one level of excitement, like the kind of excitement that Dak's having, telling whatever story he's saying instead of listening to this. Got him.
I was getting kicked in the back.
Kicking in backs does normally make me see better too. So this one gets enough energy to go to another energy level, a second higher one, the third one there. Unstable though, it falls and crashes and releases light. You have access to these slides too, so if you need a refresher to practice this for, I don't know what reason, you might have to demonstrate practicing explaining how electrons produce light or associated with light production. I don't know how you'd have to do that.
So whatever.
I don't know when you might have to do a demonstration of like how electrons produce light. I don't know when you'd have to do that. So hypothetically, in the future, if you would have to do that, it would be great to know how to do it. Maybe even refresh it, watching these videos, things like that. But more on that. Here we go. Here's another electron. Everyone say electron.
Electron.
Ground state.
Ground state.
Receives energy.
Receives energy.
Excited.
Excited.
Temporary.
Temporary.
Transition.
Transition.
Crashes.
Crashes.
To ground state.
To ground state.
Releases light.
Releases light.
Now, if you could just put that to paper on a demonstration, you'd nail it. You know what I mean? Hypothetically.
Yeah, I still feel
That's very negative. Man. I don't like that. You dang right. She's right. Flame test lab. This is how you're gonna have some flames, not all at one lab station because we only have one place to do a Bunsen burner. But your Bunsen burners will flame like this.
Well, you spoil it.
But also other colors. No, you're still gonna get the better stuff. A spectroscope or spectrometer uses lasers and diffraction gratings to basically do momentary excitements of small sets of atoms. So you can see emission-like spectrums. CDs. No, not do you see them. CDs. That's a CD, a compact disc. Yeah, no, you don't know what that is anymore. No. And DVDs. They have diffraction gratings that form certain patterns that when a laser hits it and then light passes through, when received by a certain receiver, like receptor type of thing, it causes a machine to spit out a sound or video, both,
That's cool.
associated with it.
Wow.
So like what makes a CD look iridescent is what is storing the sound and data of the music and the video and stuff.
So what happens when you like burn something to a CD?
You're literally like reordering, you're like occupying the diffraction spaces. To be honest with you, I don't really know. I mean, I'm kind of, look, I mean, that's what I'm saying is true, but it's that's a definition level. I don't know. The engineering behind these CDs, I really don't know. It's kind of crazy how someone decided to think, let me use a piece of plastic that's shiny to store music on. Then again, the cloud, you know, what is that? Tell somebody about the cloud. Okay?
A lot of scratch on a CD.
I'm just saying. All right, go
So
ahead.
that's like why when the disc becomes damaged, so like the rays can't read it, right?
Yeah.
Basically.
And honestly, I may be describing to you a laser disc, which came before compact discs. Though they do use diffraction gratings. I think I'm giving you like the lowest level of this technology. It might be more sophisticated than what I'm saying. So, to deal with that one, yeah.
When you scratch a DVD, like,
Why does it not play?
Yeah, like-
Because you messed up the diffraction rate. Like literally the hardware that stores the information is messed up.
so it's on the outside of it.
Yeah, but it's messing up the diffraction rate, which stores the information that the light can transmit through. It won't play at that part. So here's another point about this. This does actually lend to my explanation here to having some solid credence. Is some disks are not rewritable or burnable. You can't burn onto any disk, right? They have to be formatted a certain way. So that's just interesting. What? You stick it in the computer and say go.
I don't know, how does it do it?
I honestly don't know. I mean, my best case is it must organize via lasers the diffraction grading, or it's like we're only going to store information on this section of diffraction and then skip this other part because it doesn't correspond to our information. Our information is not going to be stored by that pattern of diffraction. I'm telling you, I mean, this is best guess. I don't know.
That sounded really smart.
It sounded good. It sounded okay. All right, so nuclear decay. Everybody there? Man, I've already wasted so much time. But that's okay. We're gonna be fine. I wasted so much time.
End of class.
No, so remember we did this. That's okay. We actually spent more time on this than the other classes. So this is what I had on the board for the past 2 days. I've now just recopied it more cleanly. Atoms may be unstable due to mass being sheerly too massive in the nucleus, or the neutron to proton ratio is off. Must be relieved through energetics or a mass dump. Some mass dump must occur. It must dump some mass in order to work. Okay, so mass must be dumped. The time it takes for half of a sample to dump some of its mass, and then only half of the original amount remains, is called a half-life. Hi? Okay.
We did that last.
Yeah, oh, you didn't really do it. Well, you might have really done it, but I don't think you really did it. We're going to do it. We're going to really do it. So nuclear decay here, you've got 3 kinds of decaying molecules. How many?
3.
What are they called?
Alpha, beta, gamma.
Yeah, that took longer earlier in the day. Alpha are heavy. Hey, look at this. What do you call this format?
Helium.
Complete symbol notation.
Yes.
Hello, mass number over neutron over proton number here. The alpha particle is a helium nucleus. And it can either be written like this or like this. Cool, it's heavy and slow. This alpha decay releases mass. It's a mass reliever. It's the most relief for some mass dumps. It's equivalent to pooping. I mean, it's poop. It's an unstable atom, therefore poop. Mass has left the building. You with me? Whereas beta is really just, you got intense pressure and then you belch or toot, you might say. Fart, poot. Cool? Just for all of you. And the symbol for this one, you don't like analogies? You don't like analogies? You just want me to cut you straight? Wow. That sounded sarcastic, so it sounded actually like the opposite.
Matt does it either way.
You just wait. You just wait right there, little lady. Check it out. These electrons have no mass number, and they have an opposite number of protons. They're an antiproton, right? Sort of. Did you know that there's something that has the same mass as an electron, but an opposite charge? It's called a positron.
Wow.
That's kind of cool.
It's a real thing. Like a real thing. Like it sounds like something you'd make up to an answer to a question, and you didn't really know it. Like, oh, it's called the positron, obviously.
Like something you might cross each with to get one huge natural gas in New York City.
No doubt. No doubt about that.
Where would you find
Beta decay is a ratio fixer. What, Tommy D?
Where would you find positrons in nature?
In your backyard, just go dig them up.
I don't know, like,
I'm just kidding. That's not true. Honestly, I don't think they just are roaming around your neighborhood.
I got people.
or like the universe.
I don't think they're ringing any doorbells of any galaxies anywhere nearby. They have to be manufactured, or they can happen from some sort of instability. I don't remember. I forget now. It's been a while since I've talked about positrons. So we'll just put a pin in that. Come back to you later. Beta decay balances the ratio out by turning a neutron into a proton. A neutron literally decays its heavier massness into a lighter proton by, hear me, destroying some of its mass.
Yes.
Yeah, I know we mentioned this in this class, which leads to this guy right here, energy related to mass. Mass defect relates to energy. Hello? Okay, we're going to move on from that. Gamma is just an energy. This would be like you have like a shiver, just goes through, you have chills go through your neck, whatever. You have an itch, you scratch it. Right? Alpha, poop. Beta, fart. This is an itch that you scratch. Gamma is a scratchy itchy. Yes?
Yes.
And here's an example here. The biggest thing to remember about gamma is that when you notate it, you put an asterisk by the unstable thing. Yes, asterisk. No, not a guy named Rick who's really into asteroids and comets and stuff. Asterisk. Asterisks. Plural of them. Asterisk, just for the record. Bet you didn't know that too. How about recur? You guys love to say reoccur. That's not real. Recur. There's no O in it. One vowel. Recur.
How does it even sound wrong?
Well,
It's really.
because you've heard it wrong for so long.
That's right.
That's right. Anyway, so we can keep on going on all that radiation. Here's the skills that need to be understood for decay and half-life. Identifying types using notes. Like I say, which type of decay involves the release of equivalent to a helium nucleus? Alpha. That's a notes type of identification. Another way is using equations, where we say something like, uranium-233 yields 229 thallium, thorium. A particle is released. Based on the identity of that particle, you can identify this equation representing what type of decay? Alpha decay. Are you there?
Yes.
Watch this. Beta molecule produced, beta decay. Another skill is predicting this type of equation if given an isotopic notation complete symbol. Hello? Or less. I could just tell you Lawrencium-256 alpha decays. You have to be able to know that Lawrencium-256 means LR 256 over 103 because 103 goes with LR. Hello?
Hello.
And just for the record, just so you see it one time, because I did it for the other class, I'm going to do it for you. It yields, if I'm trying to demonstrate alpha decay, it yields an alpha particle, helium, plus whatever remains. Algebra does this, basic even, like what I learned in 5th grade algebra. 4 plus what in the mass number spot equals 256. 252. 2 plus what equals 103. 101.
Wow.
Now, what symbol do I put there, Mr. Knight? I'm glad you asked. It would be the 101 symbol. Because the number 101 is the atomic number, and it goes with, corresponds to the same element. That'd be Mendelevium.
Is it really?
Which is ironic that I identified that Mendelevium from the periodic table.
Wow.
Yes.
You didn't get that? It's fine. Still, if something decays in half, a bunch of time decays, and when half remains, that is called the measure of half-life. And so, how do we find the half-life of things? Well, you could just go, divide by 2, divide by 2, divide by 2, divide by 2, or in reverse, times 2, times 2, times 2, times 2. You could do that if the number of half-lives that occur are whole numbers. Like if you cut by 2 and you were finding whole number amounts. Right? Like let's take a number 12,800. That's how much you had your bank account in the summertime. You worked your tail off. You go off to college. You have 12,800. And luckily your bank analytics, they're just on point. And they said it takes a month. You've been spending money at such a rate that after a month, half of whatever you have in your account at that time, you spend. It's almost like you're doing it with awareness. Or it's like you got excited to buy some things early on in the year and you've tapered off because you became more disciplined. But somehow, in 1 month, every 1 month, you spend half your money. So after one half-life, how much do you have left?
6,400.
It's a lot to spend in 1 month. After a second half-life, how much do you have left? So, if I asked you questions like, that's how much you started with, how much would you have left after 2 months or 2 half-lives? You could just divide by 2 twice. Divide by 2 and then divide by 2 again.
Stack super, go dog.
And then if you kept on going down this chain, what if I wanted to know, that's fine, but what if I wanted to know how much you had in your bank account after 1.843 half-lives? How do I take a half and then divide by 0.843 halves of a half? What? So it doesn't work, it's not reliable, and it works sometimes, but we want something that works all the time, every time, anytime, and on time.
Yes.
So here's what we're going to do.
What?
Nope, wait, not yet, not that. Here's what we're going to do. We have 3 equations. 1, 2, 3. But that's too soon. We have to derive one of those. So we actually start with 2 equations. We need 3. And we have to know how to satisfy these 5 figures. We have to use these 5 pieces of information from a problem and use 2 and a 3rd equation that we're going to derive in order to solve for any real number regardless of whole number status at all. Hello? This is going to be awesome. Formulas.
So, what's that in the formula again?
This is half-life. So understand some things here. Check it out. N means number of half-lives. T means time that's passed. T half means that time a half-life has occurred. In the last example I said 1 month was the half-life. Are you there? So that's all it means. And this makes sense. Look, the number of half-lives is how long total has occurred per half-life, or how many half-lives occurred inside of, divided into one total time. Are you there? And this just says, look, an amount. Look at that, A, amount. An amount of a sample is equal to how much amount was there at the beginning. This is the A naught symbol. A0, A naught, naughty, yes?
Was it?
A naught. Or A original, it means the original amount. The A of at any later point is equal to the original amount times the half-life 2 to the negative n. Now you might look at 2 to the negative n and think 2 to the negative n. What?
Yeah.
Yeah, but that's just the inverse of 1 over 2 to the n. Which just means half raised to the power of n. It's like half times half times half times half times half. That's raised to an exponent. Hello? All right. Does anyone know? So these are 2 equations. This solves for n if I have t and t half. This solves for a, or I can solve for AO fairly quickly, right? What if I need to solve for n and I don't have t and t half? I need a 3rd equation. And yes, algebra. Do you know the algebra to solve n from this equation? Do you know how to turn this equation? You haven't? No, yes you have. Do you know how to turn that equation into saying n equals something? Let's move the easy stuff. A over AO equals 2 to the negative n. All right.
Oh, that works.
See what I did there? I divided the one side away, one thing away. Yeah?
Yeah.
No big deal.
When you hit the divide.
Now, how do I get the n by itself? How do I know how to undo a multiply by, divide by. How do I undo a 2 raised to it by?
Square root.
No, what you need to do is quit picking out the specks in other people's eyes and instead pull out the log from your own.
Oh, God.
No, not God, log. Log. Logarithm. Yes. Yes. How you do it is you have to have the log of the same. Don't you pack it up yet? I got something to give you. Log of the same base to cancel those out, and then you have to do that to the other side too. But you don't have a log with a base of base 2 on your calculator. The log on your calculator is a log base 10, so you have to get rid of that. And I'm going to show you how to do that later. I got to just give you all the equations. So here's all the information. 1, 2, 3 equations. We'll finish the derivation later. I got to get you the equations and the worksheet. I got to get it to you. Got to get it to you. This worksheet, this following worksheet, you write down the formulas so that way you don't record your notes constantly. This worksheet is not due Monday because you don't come to school. It's not due Tuesday because, well, that's the first day back and I don't like to decide things over the weekend as much as I can handle it. So it is due Wednesday. But I do want you to try any 3 problems from here. Try. That means start it with something, preferably these equations. I mean, that would be nice since I am giving this. Even though I'm not talking them to you very much at all. At least try to employ them. Through the struggle, choose it through the struggle. Oh, I'm sorry. So choose through the struggle to try and employ these equations as best as you can. Try to, and understanding what all the variables mean, try to, but don't forget, here's n. N means number of half-lives. Don't forget about the 5th one. Try to use these equations with a start point and an end point on 3 problems. I don't care. They don't have to be right, wrong, and different. I just want to see what amount of progress you can find out in an autonomous environment of your own choosing. Just 3 any, try any 3 tree, try it. Okay? Also, go dogs.
Let's go, baby.
I'll just say this, when the dogs win, you win.
Yes, sir.
And that has further implications than just the
Mr.
statement.
Knight. Mr. Knight.
We'll find out later. Hopefully find out more about that on Tuesday.
If they lose, he's gonna be in a bad mood. If they win, he'll be in a good mood.
No, Luke, trust me, you will root for the dogs based on the results. That's what I'm saying. All right, good. Yeah, see if you're fighting.
Thanks for watching. Tune in next time for another edition of Night Chemistry.
Answers, ask better questions.